Objective number 3. Graph quadratic functions of the form f of x equal ax squared. In table number 7, they give a for the function g is 1/2 and function h is 2. Then they plug in the point, the x is still the same, -2, -1, 0, 1, and 2. For the function f of x equal to x squared is very simple. We just square the x. Now for the function g, we plug in the x and calculate. So we got this number. Same thing for the function h. We look at the graph and we can see the common point 0, 0, which is the vertex, are the same for all of them. So we have the number in front of the x squared. We do not need to move. In this case, the shape of the sides are changing. The original parabola is f of x. What if you have 2 in front of x squared? The function is h of x. You feel like there's someone at the end points and stretching it in vertically. And look at the function g. When you have 1/2 in the front multiply, then it feel like you are shrinking it in the vertically. Now we look at the table number 8. We see that what if we have a negative in front all of them? Then it's just exactly the same as the graph in figure 14. We have the parabola open up when we have a positive. The number in the front of x squared is positive, and is upside down when the number in front of x squared is negative. So now we're going to write down the conclusion for this. The A telling us that it's vertically stretch or shrink, right? So if A more than 1, for example, is equal to 2, then it's stretch. And if A less than 1, for example, like 1/2, is shrink. If we have negative in front of A, so we assume that A is positive in this case, okay? If we have a negative in front of A, then the parabola will be open down. Example number 6, we use the graph of y equal x squared to obtain the graph of f of x equal -2x squared. If we have a number in the front, the general idea is what do we do is we have the original graph y equal x squared. Then whatever the y value, we will need to multiply by a. The y part we multiply by a, and the x we will keep the same. So we want to use the graph of y equal to x squared. So let's look at the table for x in the input and y equal to x squared is the output. We plug in the familiar number -2, -1, 0, 1, and 2. Then we square them. And we get the graph of y equal to x squared. Now, how can we obtain the graph of f of x equal -2x squared? So let's forget about the negative. Now, we just do the f of x equal to x squared. Then the table, so we have x and y equal to x squared. What do is we keep the input the same, which is -2, -1, 0, 1, and 2. Then for the output is 4, 1, 0, 1, 4. We will multiply by a, so a is 2 in this case, so that will become 8, 1, 0, multiply by 2, so we got 8, 2, 0, 2, 8. So we double the y, that's what it means, okay? Now we plug in the new points, so we got -2, 8, -1, 2, 0, 0, 1, 2, and 2, 8. We do not move the graph, go up, go down, or left, right. It's just changing the size of the graph, and it's stretched vertically because A is positive. Now we're gonna do the minus. So very simple, we just make the parabola from the pink one will be upside down, right? So the x-axis is like a mirror. The point, let's label the point A, B, C, D. So we have the point A, for example, B, C, D, E are like this. Then the point A will be the same because it's on the mirror. What about the point B? The point B, the image of the point B was like this, and the image of the point B will be in 2 steps away from the x-axis. Similar like the point D, and for the point C and the point E, we have will be 2, -8 and -2, -8. So we make it go upside down. Okay, so that is the final answer, and we label the function is f of x equal -2 x squared.